Hello children and welcome to the session today. Let us understand about light today. So there's nothing new to light, is it? Light is there everywhere around us. In case the sun goes, the moon comes, and in case the moon does not decide to come, we have electrical switches to switch on and illuminate our houses. But children, there is much more to light. Let us understand in chapter number 15, light. So to begin with, in class 6, we have learned that light travels in a straight line. And we did a simple experiment to understand the same. What was the experiment? We took a cylinder and a candle. We placed our eye at one end of the cylinder and tried to look at the lit candle at the other end. We could see it. In case we bent the cylinder, as in this case, we were not able to see the candle. So this simple experiment showed us how light travels in a straight line. Now this was light, the linear propagation of light. Now let us understand what is reflection of light. So basically, when light strikes an opaque surface, it cannot pass through, it is reflected back. How? Let us understand with a simple experiment. To know the direction of a reflected ray, fix a white sheet of paper on a table, cut out a thin slit 1 to 2 millimeter wide in a piece of cardboard. Make the cardboard piece stand vertically on the white sheet using supports. Darken the room. Shine a torch just behind the slit. You can see the path of light on the sheet of paper. Keep a mirror vertically in the path of light so that a light ray strikes the mirror at an angle. The light falling on the mirror is called the incident ray. Note the change that happens in its path. You can clearly see the path this ray takes after being reflected by the mirror. After reflection, it is called the reflected ray. To prove that the angle of incidence is equal to the angle of reflection. In setup of activity 2, mark the position of the mirror as MN with a straight line. Using a scale and pencil, mark the path of the incident ray AO and the reflected ray OB. At O, call the point of incidence, draw a line OX perpendicular to ML. This is called the normal at the point of incidence. Measure angle AOX and BOX. You will find that these angles are equal. So in the first activity, we learned that light is reflected. And in the second activity, we learned that angle I is equal to angle R, where angle I is the angle of incidence, that is where the reflected ray touches the mirror, and angle R is the angle of reflection, where the reflected ray leaves the mirror. So based on this, children, we know that an image is formed on the mirror. Now this image can be of two kinds. It can be a real image or it can be a virtual image. So our book tells us that an image which can be obtained on a screen is a real image, and an image which cannot be obtained on a screen is known as a virtual image. Now let us understand more about this. Images are of two types, real image and vertical image. Real image is an image that can be obtained on screen. It is always inverted and is formed on the same side of the mirror when the object is placed. Vertical image is an image that cannot be obtained on the screen. It is always erect and is formed behind the mirror. If you look at your face in a plane mirror, the left side appears as the right and the right side appears as left. This phenomena is called as lateral inversion. You will notice that the image formed in a plane mirror is always of the same size as the object. It is vertical, erect and laterally inverted. It is at the same distance from the mirror as the object. After having understood this, let us now understand the nature of image formed by a plane mirror. So with these series of experiments, you will understand that the image formed by a plane mirror is virtual and it is of the same size as of the object. This experiment will tell you that the distance of the image inside the plane mirror is equal to the distance of the object outside it. Third, virtual images formed by plane mirror are laterally inverted. Let's now come to spherical mirrors. Now, what are spherical mirrors and how are they created? Let's understand that first. A mirror whose smooth and polished reflecting surface is a curved surface is called a spherical mirror. Spherical mirrors are of two main types, concave mirror and convex mirror. In a concave mirror, the reflecting surface is curved inwards. In a convex mirror, the reflecting surface is curved outwards. If you cut a hollow rubber ball with a knife, the inner surface of the cut ball is called concave and the outer surface of the cut ball is called convex. Take a stainless steel spoon and polish it by rubbing with a cotton cloth. If you bring the inner side, that is front of the side of the spoon, near your face and look into it, you will observe that the image of your face is erect and larger in size. If you move the spoon away from your face, you will see an inverted and enlarged image of your face. Turn the spoon and see your face in the back side of the spoon. You will observe that the image of your face is erect and diminished. Increase the distance of the spoon by moving it away from the face. The image of your face goes on decreasing. You can conclude that there is a change in the position, size and nature of the image formed in a smooth curved surface which changes in the position of the object. So now you understand that these mirrors are actually a part of a whole circle. What are the important terms that are connected with spherical mirrors? The first is the center of curvature. It is the center of the sphere from which the mirror has been obtained. The second is radius of curvature. Again, this is the radius of the sphere from which the lens has been taken out. Principal axis is the line passing through the center of the curvature of the mirror and the pole. Principal focus is the point where the light reflects after hitting the mirror. Now again children, these spherical mirrors have got multiple uses which we have already studied and understood. Now let us understand the concept of refraction of light. What is refraction of light? We know that when light hits a surface, it is reflected back. But what about light which enters water? Now water reflects light also and it allows light to pass through it also. So whenever light passes through water, it changes its direction. This is known as refraction. The bending of light rays when the medium is changed. So when a ray enters a denser medium from a rarer medium, it tends to move inward, and when reverse happens, that means when it is entering to a rarer medium, it will bend outward. So based on this principle, there are two types of lenses, diverging lenses and converging lenses. A lens is any piece of transparent material bonded by two curved surfaces or by one curved surface and one plane surface. Lenses are of two types, convex lens and concave lens. A convex lens is a lens which is thicker in the middle and thinner at the edges. It is also called a converging lens. A concave lens is a lens which is thinner in the middle and thicker at the edges. It is also called a diverging lens. A concave lens always forms a virtual, erect and diminished image for any position of the object. Convex lenses are used in magnifying glasses as reading glasses to read very small print of a book and is used in making cameras, telescopes, microscopes, etc. Concave lenses are used in making spectacles for people to see distant objects clearly. They are also used in certain types of telescopes. Just like the mirrors that we were talking about, the same things apply for the lenses as well. There is a principal axis, a principal focus, and the principal focus is different for converging lenses and for diverging lenses. Now children, you all have seen a rainbow in the sky. what is this rainbow actually happening? Here what is happening is the ray of white light is being split. How is it being split? It is split into 7 different colors. 1, 2, 3, 4, 5, 6 and 7. These colors are known by the name Vibgyor. Violet, indigo, blue, green, yellow, orange and red. So all of these colors combine together to form white light. And if you actually want to create a rainbow, what do you need to do? You need to use a prism. And this 7 colors that we have created here, they are known as the spectrum. So in this chapter, what have we understood? We have understood the concept of light. We have understood how light travels in a straight line. What is reflection? What is refraction? What are real and virtual images? What are the kinds of mirrors and lenses? I'm sure you're ready to take on the exercises now. Thank you.